Okay, carrying on. So this is a simple tax bracket question. And it's also an OCW question. So for these extra 2 marks, we are expected to be organized and coherent. Okay, so Agata is paid in pesos. The tax rates are as follows. So up to 200,000, they pay 0% tax on that. The standard rate for the money between 200,000 and 500,000, they pay 10%. And anything above 500,000, they pay 35% on. So let's calculate the tax for each of these brackets individually and then add them up. So PA, there's 20,000 in that bracket of the 600,000 that they're paid. So that's 200,000 in that bracket and it's taxed at 0%. So the multiplier for 0% being 0, so they're taxed £0 on that part there. So for the standard rate, this bracket is full, so it would be 300,000, and then they taxed at 10% of that, so times by 0.1. 10% of 300,000 is, and I shouldn't write that actually because it's pesos technically, so pesos, and then so 10% of 300,000 being 30,000, so 30,000 pesos, and then we'll do the further rate. So they paid 600,000 and anything over 500,000 is taxed at 35%. So this would be 100,000 at the 35% rate. And the multiplier for finding 35% is 0.35. And this is quite a nice one because it's just simply 3,500 pesos. So in total, the total amount of tax paid is 0 plus 30,000 plus 35,000, so it is 65,000 pesos total. So how much tax are they due to pay? So 65,000 pesos total. And that's deceptive because that's not actually that much work for 8 marks, I think. So Gwilym is stacking 6 boxes in his garage. The height of his garage is 2.5 meters, correct to the nearest 10 centimeters. 5 of these boxes have a height of 4 centimeters, correct to the nearest 10 centimeters. The other box has a height of 55 centimeters, correct to the nearest 5 centimeters. Calculate the maximum possible gap between the stack of 6 boxes and the garage roof, a garage ceiling. So this is an upper and lower bounds question. So essentially we're going to look at the resolution for each and then take half of it either side. So let's do height first of all, so H for height. So the height is 2.5 meters, so that is 250 centimeters. And we know that it's 10 to the nearest 10 centimeters. So the resolution here is 10. So 10 divided by 2 is 5. So it's 5 either side. So the biggest the height could possibly be is 255 centimeters. And the lowest it could be is 245 centimeters. So note that this one is a less than or equal to, because if it's at 245, it would round up to 250 centimeters to the nearest 10, because we're going to the nearest 10. But if it was 255, it would round to 260, so we don't allow it to be equal to 255 exactly. We use this strong inequality here. Right, so the next one then, so the height of each box is 40 centimeters each, so the height of the box, and again to the nearest 10, so 10 divided by 2 being 5, so it's 5 centimeters either side. So each box is measured to be 40 centimeters, but height biggest it could be is 45, lowest it could be is 35. And then the other box, so I'm going to put that as OB, other box, has a height of 55 centimeters, but correct to the nearest 5, so it's 5 divided by 2 being 2.5. So the biggest it could possibly be, it's measured as 55, so above the biggest it could be is 57.5, and below the smallest it could be is 52.5. And now that we have these, we can actually work out the question. So calculate the maximum possible gap between the stack of 6 boxes and the garage ceiling. So here's the garage ceiling, and then we have our 6 boxes, and then obviously we're looking for this difference here. So we want to find the maximum possible gap between the stack of 6 boxes. So to do this, we want to maximize the height. So we want the ceiling to be as tall as possible, and we want the boxes to be as short as possible. Maximum is height, minimize boxes. So we're going to use this value here, and we're going to use these two values here. So 5 boxes each, so each box is 5, so these are each 35, so 35 times 5 here. This we're taking to be 255. And then this last box we take to be as small as possible, which is 52.5. So 35 times 5 being, so timesing by 10 is 350, and then halving is 175 centimeters. And then we add on the 52.5. So adding 25, that's 200, and then 227.5 centimeters is the total height of boxes, total box height. Equals 227.5, and then the biggest possible height for the ceiling was 255, so gap size would be 255 take away 227.5, and you can do this with any method you like, really. So 255, let's do it as a column, subtract 0.0, take away 227.5. So cancelling this, 4, 1, so 5, 4, 7, 2, 0. So it is 27.5 centimeters is the maximum possible gap.